Oh. Moving right along, today we are in lesson 4 of chapter 11, and we are moving from 2-dimensional land to 3-dimensional land. Okay, today we're talking all about 3-dimensional figures. And your learning goal today is to be able to identify, describe, and classify 3-dimensional figures. What does it mean to identify something? Like I can say, ooh, I identify you, you're Tanvi, and I identify you, you're Rashika, and I identify you, you're Soham. What does it mean to identify something, Liam?
It means to look at something and tell what it is.
And say its name. Look at something and say its name. We also need to be able to describe. How do I describe something? Siddharth?
Like some things about like its traits and attributes.
Tell about its properties and traits. Yeah, we need to be able to describe 3-dimensional figures. And finally, we know that classification means what? Rashika?
So it's like you're able to put them in separate groups.
Yeah.
According to their properties.
Yeah, to classify means to sort them or put them into separate groups, like maybe into a Venn diagram or different boxes, depending on their properties. Okay, we can do that. So again, with our problem of the day, we were classifying figures, but were we classifying 2-dimensional figures or 3-dimensional figures? 2. So today we're going to basically do the same thing, but with 3-dimensional figures. Okay, the first thing we need to clarify is what makes a 2-dimensional figure a 2-dimensional figure, and what makes a 3-dimensional figure a 3-dimensional figure? Well, a 2-dimensional figure has 2 dimensions. That's why it's called a 2-dimensional figure. What are the 2 dimensions of a 2-dimensional figure? Jason? Like if I have this figure right here, would you agree that this is a 2-dimensional figure? What 2 dimensions could I use to maybe find its area? Jason? Well, that's a different math idea. Shreya?
Length and width.
Yeah, it has the length and the width. Okay? There's 2 dimensions in a 2-dimensional figure. Now, a 3-dimensional figure is sometimes also called a solid. It has, guess how many dimensions it has? 3. It has a 3rd dimension, which is the height. Okay? So, if I were to take my 2-dimensional figure, okay, and now this is the width, and I add a 3rd dimension right here, which is the height. That's why 3-dimensional figures are called 3-dimensional figures, because they have 3 dimensions. The length, how long it is, the width, how wide it is, and the height, how high it is. These 3 dimensions are used to find the figure's volume, okay, or the amount of space it takes up. Does every 3-dimensional figure have volume?
Yes.
Does this stack of Post-its have volume?
Yeah.
Because it has a length, it has a width, and it has a certain height. Does Rex have volume?
Yes.
Because Rex takes up a certain length, it takes up a certain, length, takes a certain width, and he takes up a certain height. All 3-dimensional figures have a length, a width, and a height. 3 dimensions that together we can use to find out how much space it takes up. Okay? So as we know, and I want you to write in your notebooks, a solid figure has 3 dimensions: length, width, and height. A special vocabulary word for you is a polyhedron. Everyone say polyhedron.
Polyhedron.
Polyhedrons are 3-dimensional figures such as prisms and pyramids. They're 3-dimensional figures that have faces that are polygons. There are 2 kinds of polyhedrons we just wrote about, right? What are they? A prism or a pyramid. So let's take a closer look to see what makes a pyramid, and a prism, okay? And of course, you'll take good notes in your notebook by writing down these vocabulary words. A prism is a polyhedron that has 2 congruent polygons as bases, okay? A polyhedron's lateral faces are polygons that connect with the bases. So you'll see this green polygon is what polygon? It's a triangle. You can see that there is a congruent triangle at the bottom, at the base, right? So these 2 bases are congruent triangles. These faces, the ones that connect the 2 triangles, are called lateral bases, okay? And you call a prism by the shape of its base. So what is the shape of this base again? A triangle. So because this base is called a triangle, this prism is called a triangular prism. Okay? And you can have lots of different kinds of prisms. You might have a decagonal prism. What polygon would be at the base of a decagonal? A decagon, or a polygon that has how many sides? 10. You might have an octagonal prism, which means that the two bases at the top and the bottom are what polygon? Octagon. If you have a hexagonal prism, you have two bases that are six-sided, or a hexagon. Okay, if you have a pentagonal prism, you have how many pentagons do you have in a pentagonal prism? How many pentagons would you have in a pentagonal prism? 2. How many sides does a pentagon have, though? 5. Okay, thank you. If you have a rectangular prism, how many rectangles would you have? 2. If you have a triangular prism like this, how many triangles do you have? 2. Okay? There is another type of polyhedron. Remember, a polyhedron is a three-dimensional figure where every single face is a polygon. Do they have to be the same polygon? No, you can have different polygons, okay? So there's a different kind of polyhedron called a pyramid. A pyramid is a polyhedron with only one base. The lateral faces of a pyramid are triangles that meet at a common vertex, that meet at one point, okay? So right off the bat, what are some similarities between prisms and pyramids? What are some things that are the same between when you compare a pyramid and a prism? Marcus?
They both have lateral faces.
They both have lateral faces. Sarah?
They're both polyhedrons.
They're both polyhedrons. They both have faces that are polygons. Siddharth?
They both have at least one base.
They have at least one base. They are also both three-dimensional figures, right? What are some differences between pyramids and prisms? Like if we made a T-chart, which you can do right now in your notebook, what are some differences between prisms and pyramids? Whoa. Okay. What are some differences? Neha?
Well, pyramids, they only have one base.
Oh, pyramids have one base, and prisms have two bases. Okay. Rashika?
Actually, no. I was thinking prism.
Let's compare the lateral faces between a pyramid and a prism. Yarden? Ah. Okay. So in a prism, we have lateral rectangles, and in a pyramid, we have lateral triangles. Okay. Another similarity, though, is that prisms and pyramids, we identify them based on the polygon that is their base. Okay, just like we called an octagonal prism because it has two congruent octagons as bases, we can use the shape of the base to name our pyramids. Let's take a look. What is the base shape here? It's a triangle. Okay, go ahead and write that down. So then if it's a triangle, then we call this a triangular pyramid. And you can see that in the word bank right here. Triangular . Now, how do you know that this is a pyramid and not a prism? How do I know that this is a triangular pyramid and not a triangular prism? Zara?
Because it only has one base.
It only has one base, and what else?
The lateral face is a triangle.
And the lateral face is a triangle. It's not a rectangle anymore. Jason, let's take a look at the next one. What is the base shape of the next figure? It's a square. Okay, so this is a square. Then what kind of solid figure is this? We could be even more specific. Look at your word bank.
Square pyramid.
We can call it a square pyramid. Make sure you can write this down so you have your notes. How do you know that this is a square pyramid and not a square prism? Soham?
Because its lateral sides, they're triangles, and it has only one base.
Its lateral faces are triangles, and there's only one base. Also, do the lateral faces meet at one vertex, one point? a pyramid must have one point where all the lateral faces, the triangular lateral faces, are meeting. All right, let's take a look. What is the base shape here? It's a pentagon. So what is the solid figure? It's a what? Thank you. Pentagonal. And how do I know that this is a pyramid and not a prism? Sarah? Pyramids only have one base. How else does Sarah know? Tanvi?
Well, she knows that the lateral faces are triangles instead of like in the pyramid and
Yeah.
but in the prism they're rectangles.
Yeah. And also, the pyramids meet, all the lateral faces meet at what? Meet at one vertex. In the prisms, do the lateral faces meet at a vertex? Right? No, they do not. They meet at the other base, or they go to the other base. There are some three-dimensional figures, as we've discovered, that are not polyhedrons. And you will see this in your book, and you might also want to take notes. Some three-dimensional figures have curved surfaces. These are solid figures that are not polyhedrons, and here are some examples. A cone has a circular base, right? The base is a circle, and a curved surface. How many bases does a cone have? One. And the shape of a cone is? A circle. Does it have any lateral faces? No, because it's curved, right? It does meet at one vertex, but it's a curved surface. There's no triangles or rectangles as the lateral faces. A cylinder has two congruent circular bases and one curved surface. A sphere has no base and a curved surface. So my question to you is, why are these not polyhedrons? They are three-dimensional. How come these are not polyhedrons? Turn and talk with your group.